Okay guys, so this is one example in a series of examples that I will be solving as tutorials for your preparation for your midterm. Okay, now this example is easy, but since many of you make a mistake in an essential mistake related to the concept of series and parallel connection, I want to solve this one in two different ways, or actually in two different with one modification. So the first idea is let's put some numbers. So let's say that R1 equals 10, R2 ohms, of course. R2 is, let's say, 6 ohms, R3 6 ohms, R5 12 ohms, R4 12 ohms, and R6 6 ohms. Okay, so we have this guy is 12, this guy is 6, this guy is 12, this guy is 6, this guy is 6, and this guy is 10. Now the problem or the mistake that many of you make is actually the following. They consider that R5 and R6 are in series, or R3 and R4 are in series, and that's not true. The definition of a series connection means that the same current that passes through one element is passing through the other element. So the current that passes through R5 is the same that passes through R6. But in this case, unless it is a very special case, it is not, since this current that goes here is going to either split into one part here, one part here, or some other current is coming from there to support it. So this means that when there is a disconnection between two elements, then these two elements are not in series. So you have to pay attention for this fact. Since those are not in series, you cannot treat them as in series. Rather, we start with the fact that this one and these 2 points are the same points. So this R5 and R3 are in parallel. R4 and R6 are in parallel. Their total or their equivalents, they are in series with each other. So having said that, let's see what is the solution for this one. So R3 parallel to R5, that gives us 12 times 6 over their total, which is 18, and that is 4. The same thing goes with R4 parallel to R6. The result is 4. So that now our circuit is actually this one. There is R1, R2, then the two equivalents 4 and 4. Okay, so this is the circuit. So this guy is 4, this guy is 4, this guy is 6, and this guy is 10. And now we have the two 4s now are in series because they have the same current that goes like that. So that is 8, 6, and 10. Now the 8 and 6 are in parallel. Again, one of the mistakes that I saw in some of the work that you submitted, the fact that you consider that this resistance here and this one are in series. That's not true. Again, those are not in series, guys. So because there is this, if there is a current going through this one, then that current is either going to split into two like that, or it is going to get some current from up, whatever that there is. That current is not the same current that goes like here. So this resistance and this one are not in series. Rather, these two are in parallel first. This is solved, and then you find the equivalent that you are looking for. So now to find, now this color, the yellow, is a little bit annoying. Maybe this one. So 6 parallel to 8 is 6 times 8 over the total, which is 14. and that equals 6 times 8 is 48 over 14. Now how much is that? That is equal approximately 3.4. So the total is 10, 3.4, and that is 13.4 ohms. Now the other way around, if we remove this connection, if we remove this connection here, okay, in that case R5 and R6 are going to be in series, R3 and R4 are going to be in series, their totals are in parallel, and the total of those totals in parallel with R2 and so on. Let's do that. Okay, so what we are saying now, that there is no line between the joint, these 2 points, the joints of these, so there is no line there. That means this R5 and R6 now are in series because there is one current goes from in both. The same thing, R3 and R4 are in series. So if we calculate this, the total of R5 plus R6 equal 18, because one of them was 12, the other one was 6. The same, R3 plus R4 equal 18. Now 18, so this means this circuit becomes this one. This is 6, this is 18, this is 18, and this is 10, right? So the parallel of these three, the parallel of these two is 9. 18 times 18 over 36 equal 9. The parallel of 9 with 6 is 9 times 6 over 15 by 3. This is 5 by 3. This is 3. So it is like 18 over 5. And this is, okay, this is around 3.6. So the total is 13.6 with a small difference between the two values. Of course, if the values of the resistances were different or chosen differently, then these values will be, of course, different. I hope this sheds some light on the fact that how you should consider a connection, a series one or parallel one. Okay, see you in another example.